everyone, and thanks for watching Edupedia World videos. In this video, we'll study another method for calculating the integrals of complicated expressions, and this method will be integration by using partial fractions. This method will be applicable for rational functions, and we know what they are already. A rational function is a function of the form of p of x by q of x, where p and q are both polynomials. And we can often break down rational functions into simpler expressions whose integrals we already know. So first we look at the few integrals we already know. We know integral of 1 by x dx is equal to ln x plus c, but there's one small addition here. For ln x, the argument can never be negative. X has to be always 0 or positive, not even 0 actually, for ln x to be defined. But 1 by x can obviously be negative, and when we go into the negative range, the integral is pretty much the same, so we put ln of mod x. This is the actual integral. If we know that x is always going to be greater than 0, then we don't need to put the mod, is superfluous, but otherwise the integral of 1 by x dx is ln of mod of x plus c. What about, say, the integral of 1 by x minus 2 dx? What do you do then? Well, you can simply substitute x minus 2 is equal to something else called y, and what you'll get is integral of 1 by y, and from this you can see that dx is equal to dy, which gives me ln of mod y plus c, which is ln of mod of x minus 2 plus c. Wherever x minus 2 is positive, this is x minus 2. Wherever it's negative, this is 2 minus x. So 1 by x, we know the integral. 1 by x minus 2, we know the integral. 1 by x square, what is the integral of that? Well, that's pretty easy. You can just use the formula x to the power n plus 1 by n plus 1. N here is minus 2, so we'll get x to the power minus 1 by minus 1, or minus 1 by x plus c. If you have something like 1 by x minus 3 whole squared, then once again you can just put x minus 3 is equal to t, or y, dx will be dt, and what you'll get is minus 1 by x minus 3 plus c. So basically we know how to calculate the integral of any form of expression, which is of the form of x minus a whole to the power b, 1 by x minus a whole to the power b. If a is 0 and b is 1, if b is 1 in any case, it will be logarithmic. If b is any other number, then it will be a rational function. Now the goal is to basically divide or to express this rational function into sums where each sum is in the form of 1 by x minus a whole to the power b. And that can usually be done, so I'll just tell you the forms which it will take, and then you can use your own substitution to calculate the values of the coefficients. So if you have to calculate the integral of, say, px plus q by x minus a into x minus b, so you can always write this, as long as a is not equal to b, you can always write this as a by x minus a plus b by x minus b. If you can write it in this form, then you know the integral, as long as capital A and capital B are constants. Right? So our goal is to write this expression in this form, and after that we'll know the integral. This will be a times log of mod x minus a, this will be b times log of mod of x minus b. So how do we write it in this form? Well, you just multiply. So this will be a times x minus b, or ax minus ab, plus bx minus ab by x minus a into x minus b. Right, a, b, p and q are all knowns. The only unknowns are capital A and capital B. From this you can get the numerator will be capital A plus b times x minus a capital B plus ab by x minus a into x minus b. So capital A plus capital B is equal to P, and AB plus AB is equal to minus Q. You have two linear equations in two variables A and B. You can obviously calculate the values of A and B, and then you will get this form. And that is the essence of integration by partial fractions. Now I'll just show you different forms which it will take for different expressions, and you can easily cross multiply in the numerator and get the coefficients. If you have, let's say, so this was as long as A is not equal to B. What about if A is equal to B? Which means if you have Px plus Q divided by x minus A whole square. What do you do in this case? Well, you try to write it as A by x minus A plus B by x minus A whole square. So these are the two terms. You know the integral of these two terms. This will be A log of mod x minus A, and this will be minus of x minus A, minus of 1 by x minus A, because the integral of 1 by x square is minus 1 by x. What if you have an even more complicated expression, px square plus qx plus r, a quadratic equation in the numerator and a cubic in the denominator, which if there's a cubic in the denominator, you can factorize it as x minus a, x minus b, x minus c, assuming it can be factorized. And you can always write this, it is similar to this, so it will be capital A by x minus a plus b by x minus b plus c by x minus c. Now you have three variables, but you will also get three equations for three coefficients, x square, x, and the constant 1, and you can calculate the values of a, b, and c. And you can just do it for more complicated expressions in a similar inductive manner. I'll just show you one more. If you have px square plus qx plus r, and two of these happen to be the same, so let's say x minus a whole squared into x minus b. Well, then what you do is a by x minus a plus b by x minus a whole squared plus c by x minus b. Right. So this is the method of partial fractions, and once you have it in this form where capital A, B, and C, small a, b, and c are all constants, you can obviously calculate the integral, because you know the integrals already. It will be either polynomials or logarithmic. In the next video, we'll see the final method to calculate the most complicated forms of integrals, and that will be called integration by parts, and that will be an analog of the product rule in differentiation. When we had the chain rule in differentiation, the analog of that was substitution, and we also have the product rule in differentiation. We'll use the product rule to calculate integration, calculate a method of integration known as integration by parts. Thank you.